gosh, okay. How do we just ban IPs on this thing?
You can look at the right keys and be like, oh.
Yeah, it's .100.154.
Ping Dawson.
Yeah, that'd be fun. Alrighty, welcome to DevSec. Tonight I'm going to be talking about some initial exploitation of what people are going to do when they come at you with their Kali boxes and all that good stuff. And then we're going to go over how to block all those initial exploits and a little bit of post-exploitation, blocking all that good stuff after the fact. So yeah. First thing I wanted to go over today was kind of some of the takeaways from. Okay, that didn't work. From Cyber Conquest. Kind of the biggest thing I noticed was like I'd walk around and there'd be like a whole bunch of services. There's one service called LDAP. There's another one called RDP, SMB. One of the did anyone operate the Winix box at all? Yeah, the Winix box was like actually I think a secondary domain controller or something like that. And so I think the SSH service on there was actually controlled by LDAP. So your service right there was also heavily dependent upon LDAP. So yeah, one of the biggest things I noticed was like I'd walk around, people hadn't changed their password in the scoring engine. Therefore, they made like 5 of their services go down at the same time. As soon as that was fixed, all the services, like 5 of them went back up and it was all good. Yeah, so don't forget your DA password. Your domain admin password is kind of important. That's kind of the guy that controls your entire domain. So make sure, like, if you change the password, not to lose that. Otherwise, you're going to have to revert it or try to launch a few exploits on that thing and get rid of it. It's running on the system. Tell your hackers how to take advantage of the services. One of the examples I kind of want to share here is on the Windows server box, there was an FTP file share, and you kind of could have went on your file share and like looked at your FTP users and all that stuff and told your hackers like, hey, like this guy's got an FTP share over here, like use these creds to get in and like delete the file and make the other people lose points and all that good stuff. And communicate with your teammates. Basically, like if your domain admin is going to change all the passwords at the same time, you kind of want the rest of your teammates to know that. And be prepared. Like when you go in there, you want to have certain people have different roles. Like you want to have Windows defenders, domain admin. You want to have Linux people. You want to have your hackers. You want to know who's going to operate at what role before going in and all that stuff. Yeah. So first off, we're going to go over a little bit of terminology, what we're going to go over today. Vulnerability, that's going to be a weakness in the software system. Exploit, an attack that leverages a vulnerability. Initial exploitation, that's the process of getting initial access to a system. We're going to be talking a decent amount about that today. Post-exploitation, this is what happens once initial access is gained. CVE, a vulnerability score based on the severity of a weakness. SMB V1, Windows version of a server message block file sharing protocol. We'll go over these a little bit more in depth in a bit here. And lastly, the main thing we're going to be talking about today is the firewall. That's a security appliance designed to block unwanted traffic. So first off, we want to go over vulnerabilities versus exploits. A vulnerability, that's a weakness in the software system. An exploit is literally just going to like take advantage. It's going to take advantage of that weakness. People are going to like craft an exploit and make a proof of concept to prove that, hey, this thing's vulnerable and we can actually, it's exploitable. So that's kind of the difference there. This slide up here kind of goes over, shows a really good visual of that, of the whole process of like from initial exploitation to reaching a computer system, dropping like your payloads and all that good stuff on it. So yeah, basically the first one goes over attackers create exploits to target the software vulnerability. Then they're going to try to come at you with all these kind of all these things, like they're going to try sending their payloads through emails as an initial attack vector. They're going to try launching exploits. They're going to try all kinds of stuff. So yeah, and then once they get access to it, they're going to drop their payload, and then there's going to be typically something that's going to call back to the attacker and you're basically pwned. So yeah, got any questions so far? Why is there a size limit to my complicated questions? Good question. So CVE'S and the CVSS. CVE is a common vulnerability exposure score. That's going to be like, that's the naming convention and public definition of all the vulnerabilities and stuff that have been released and identified. And there's, I think the URL of one of the things is called ExploitDB, is where you can like look at all these exploits that have been launched for, or that have been, or all these vulnerabilities that have been identified on a whole bunch of systems. CVSS, each one of these CVEs is going to get like a CVSS score. A lot of the exploits we're going to go over today are going to have like basically a 10 on a scale of 1 to 10. So like a 10 is pretty critical, and that's something you really, really want to patch, take care of, and make sure that your systems aren't going to be vulnerable to that stuff. One of the things that kind of you can implement into your network is like vulnerability scanners are going to scan your systems and find all this good information. Some of the big names here, OpenVAS, that's the open source one that's like pre-installed in Kali and all that good stuff. Tenable, we're gonna have Rapid7's, Nexpose, and that's basically the vulnerability scanners that you're gonna find out there in this day and age. Basically, you can put credentials. You can run uncredentialed scans and credentialed scans, and you can really get a deep perspective of what's going on inside your system and what's vulnerable. And one of the biggest things, or one of the things we're going to be talking a little bit about today is patches. This is a nice little graph I pulled from our local SBS Cybersecurity Institute. Basically, as a sysadmin, you're going to get a new patch. You're going to acquire this patch. You're going to test the patch on on a different system that's not in production. Then you're going to deploy the patch, and then you're going to review the deployment. And basically, what we're just going to do on our Windows box is just click Windows Update and call it a day, and hopefully nothing breaks. But yeah, if you're in an enterprise security environment, this is ideally what you'd want to do. And kind of implementing this into the security strategy in CCDC. It's very good for competitions like that. Like say for Cyberforce and Ice Age and all that stuff, you're gonna get a bunch of machines ahead of time to work on and kind of fix and stuff like that. And you're gonna have a lot of time to find all the vulnerabilities and stuff. And having a vulnerability scanner in this environment is almost it's a no-brainer. You really want to do that. You're going to be able to fix a lot of the stuff that the red teamers are going to try to exploit once you get to like Chicago and Iowa State and all that stuff. And if there's time in your CCDC style of competitions, these are like the 4-hour competitions. If you have someone that knows how to get one going quickly, then it's a good idea to use one. So some of the biggest things we're going to be talking about today is PSExec. That's basically sysinternal suite tool. MS08_67_net API. That's gonna function. It's gonna leverage and exploit in some of the SMB net API capabilities. And then we're gonna go over Eternal Blue. This is a really interesting one. There's a lot of systems still vulnerable to that today. And the most recent one called Bluekeep. So PSExec. I've talked to a lot of red teamers, and this is kind of one of the main ways that they're going to get into a system, or this is their go-to way. This is what they start off with when they're trying to get into a Windows system. And basically, it was a tool developed by Microsoft to like take over Telnet, because Telnet it's pretty awful. And yeah, it can do has a lot of remote management capabilities and stuff like that, and it's gonna operate over SMB. And lastly, Metasploit has a lot of really nice modules to take advantage of this. I was kind of reading on it the other day, and it was actually pretty scary, the capabilities of the PSExec modules that they have. They're not super easy to detect either, so keep that in mind. And then remediation. change your credentials and stuff like that, and so they can't get in the first place, drop any of their modules or anything, or connect to SMB. Block port 445. Essentially, this is going to render your SMB service unusable. So like, you only want to do that, block port 445, if your computer doesn't need to utilize the SMB service at all. Basically, if there's a client machine that's just on the network and you don't have anything, you don't need to do anything with it, then leave it like that. MS08 _67 net API. This one leads to a total and complete system compromise. It has a CVSS score of 10.0. This is going to affect your Windows XP and your Windows 2003 machines. Basically, Windows XP, this is a super reliable exploit. Windows 2003, it's going to be a little bit more difficult, like the attacker might crash your system or something like that after 2 tries, or if anything gets fudged in the slightest of ways, it's not going to work and probably blue screen your server. So yeah, so this is one you want to be aware of. Also operating over the SMB port 445. Yeah, Windows 2000, XP 2003. Remediation, we're going to patch the system, we're going to update, we'll go over that in a little bit. Block inbound ports 445, 139. Again, this is going to completely render your system, your SMB service unusable. And lastly, thirdly, Eternal Blue. This is a really reliable exploit that they're going to use against Windows 7 and Windows 10 and Server 2016. So it's a pretty deadly exploit that you want to be aware of and make sure your systems aren't vulnerable to that. Basically, it was developed by an ATP group called the Equation Group. They've been identified as like probably one of the most sophisticated APTs in the world. And yeah, that got stolen by a different hacker group, and that hacker group just like slightly kind of released it and threw it in their WannaCry, or someone used it, and I can't remember if it was them or someone else that used that exploit in WannaCry, and they encrypted over 200,000 systems with this, which is pretty incredible. Yeah, so I mean, once a computer has been exploited with that, it's going to be, the attacker's going to be operating at the system level, and you're basically pwned. Unless you can get them off. Affected operating systems, from my understanding, basically every version of Windows that supports SMB V1 is going to have that. So the remediation for this one is a bit nicer. You can just disable SMB V1. Your Windows 7 and your Windows 10 operating systems are all going to be, they're going to have SMB V1 installed on them, but they're going to be actually using SMB v 2.1. And basically SMB V1 is just for cross compatibility. So like if someone's running a Windows XP or a Windows 2003 or a Windows 2000 box, they can still communicate with the file shares on those systems. So yeah, it's pretty trivial to just disable SMB V1, and then they won't be able to exploit that. You can patch with the latest Microsoft update. Block ports 445, 139. Again, that's going to render SMB pretty useless from someone's trying to get to one of your servers. And this is kind of what happens if Windows Eternal Blue. If let's see, this screenshot I pulled from, I was trying Eternal Blue on like a system that was updated and all that stuff, and I think this update was from 2018, and it still did some stuff to it. But basically, if an exploit fails, it's going to crash your system, and typically it's going to blue screen or crash your system, and that means that you still have time to hopefully save yourself as long as they didn't destroy your computer. Bluekeep, this is the newest one out there. Basically, that's a CVSS score of 10, which basically means if an attacker exploits that, there's going to be complete and total system compromise. From there, again, an attacker can do all that stuff, drop a really neat payload to get them to establish persistence and do all the good stuff that hackers do. affected operating systems. Bluekeep, this particular one, this Metasploit module, the public community Metasploit module is only going to affect Windows 7 and Windows 2008. So, but there's also another one called Deja Blue that's going to affect like Windows 10 in 2016 and 2019. But that's not going to be something that's going to appear in CCDC, probably. I know Deja Blue's been used in the wild a bit. Remediation, patch the system, block inbound port 3389, turn off RDP if you don't need it. And so yeah, it kind of gets us to the firewall. We can block a lot of this stuff with the firewall and make make the attackers have a really difficult time doing like anything to us, which is kind of funny. It's really fun actually. Yeah, so basically a simple definition of the firewall is it's just a security appliance that sits on the border of your network and it's just going to block traffic that doesn't need to be there. A lot of these firewalls these days are pretty sophisticated. They operate. Some of them operate VPNs. They have IPSs built into them. They can act as a decryption broker as well. So like, say if you're applying like a whole bunch of defense in depth principles, you can like it's going to take that cert and it's going to decrypt all the traffic, send it to the computers, send it to the computers on your LAN, and like other security appliances. Like say you have a DLP solution going, they're going to be able to decrypt all that and identify credit cards and all that good stuff. And social security card numbers going through the wire. Because that would otherwise be encrypted. That's kind of a little bit of what a decryption broker is. Some of them even act as a web proxy as well. Yeah, and yeah, a lot more features that cost around $100,000 a piece to enable. Some of these firewalls, like Palo Alto, Juniper, and all that stuff, they get super expensive. So the kinds of firewalls that you're going to, there's two types of firewalls. There's a stateful firewall and a stateless firewall. Basically a stateful firewall, that guy is going to, he's going to understand the connection, the state of the connection. Basically they're going to know the three-way handshake. They're going to have like a table of all the established connections. And as soon as the firewall detects like a RST packet or a FIN packet or something like that, it's going to know that it's going to start blocking that connection. Any further inbound connections from or outbound connections from that service. And for like a connectionless protocol like UDP, there's just going to be a little timeout on that, and then they're going to consider that thing terminated. A stateless one, this one does not keep track of the state of a connection. It's just going to look at the packets. It's also known as like packet filtering. Like you're going to have to. So say you have a host machine. You have your network firewall right here, and you also have your random server you're trying to reach out to. You're going to have to establish like inbound and outbound rules for both those ways, for both directions rather than just one. So that's kind of annoying, but it's just a little bit more work to set up, I guess. Uses less resources because it's not like spending all the resources sitting there looking at understanding the session states and stuff like that. So yeah, this is kind of what your network firewall system or setup is going to look like. You're going to have your firewall up here, or sitting on the border of your network, and then you're going to have a LAN with all your host computers and stuff like that. And each of your host computers is also going to have a firewall. I think Mike is going to be talking about the network firewalls in a different module. Today we're going to be talking about the Windows firewall and stuff like that. So yeah, network-based firewalls. These are the firewalls that are going to they're going to sit on the edge before the traffic enters the network. Kind of went over this. Separated into different zones, like you're going to have a server sitting in, you're going to have servers, web servers and all that stuff sitting in a DMZ, and they're not going to be able to talk to like your LAN at all. And it's just a way of segmenting your network, so if an attacker gets a foothold in one section, it's not very easy to get to the other, or almost impossible. Yeah, so some of the brands you're going to hear. Palo Alto, they usually gave us these for CCDC. They're super powerful in stopping out and blocking our attackers because of Palo Alto just has so many features built into them that it makes it super difficult for attackers. Juniper, we haven't really had those for CCDC. PFSense, this is one you're probably going to be interacting with the most during our competitions and all that stuff. It's open source, which also means that the red team can sit there and make custom modules and all kinds of stuff. I heard one story where they literally made a user that the PFSense admin couldn't see, and then they also exposed the web page to the external. The admin page was externally facing, and the people operating it had no idea because they just basically changed all the code for that. It was super interesting. Cisco ASA, that's another one. ForcePoint, they've got a little bit of a product going out there. I don't know. Haven't read a whole lot about that one. Host-based firewalls. This is going to be the firewalls that are hosted on the system and not the network. Do any of you know what the firewall that's on a Windows machine is called at all? Yeah, so that's going to be called the Windows firewall, basically. Yeah, super neat naming scheme there. And then Linux, Cutshot's going to be going over IP tables in a bit, or UFW. And yeah, that's going to be our nice logo for Windows. And then for the Windows firewall operations, this is kind of, you can open up your virtual machine and kind of follow along if you want here, or I'm going to go over a demo afterwards. Actually, you know what? I think I'm just going to skip through all this stuff. Never mind. I'll just go through it. So yeah, basically just type in firewall in the search bar. You're going to come up with all this good stuff. You're going to want to make sure that your firewall is turned on. So for your host-based firewalls, there's 3 profiles you want to be worried about. Those are going to be your domain, private, and your public or guest one. They might be called different. There might be a few different ones, depending on if you're running Windows 10 or Windows 7. I think Windows 7 has something called home group or something like that, which is basically private. So yeah, Windows Firewall, going into your advanced settings, you're going to be provided with a plethora of options. Right away when you get on a computer, you're going to want to make sure that all your inbound connections that don't follow a rule are blocked. That's just on there by default. And depending on if that's misconfigured or not, I don't know. It really depends on whoever set the system up. And then the inbound and outbound connections. This option's gonna for the inbound ones, like I said, they're gonna be automatically blocked by default. It's still gonna allow most of these exploits to be completed because typically your default's gonna still have your SMB service open. And your RDP stuff, your RDPs, your remote desktop protocol service running and all that good stuff. And yeah, so we'll have to get into a little bit more how to stop all that. Windows Firewall inbound connections. Oh yeah, so another setting here is you can block all the connections going into the system regardless of whether there's a rule set up for it or not. This is there's a few advantages to this, you'll have more time to harden your system and change all your users and passwords. But you also run the risk of getting SLA violations and all that stuff. And this one it's really nasty for the red team. This option is going to block all your outbound connections that do not match a rule. So if you weren't able to patch your system in time, you weren't able to stop the exploits right away, you can, if you have enough time, you can like implement outbound egress firewall rules that basically make it super difficult to run anything on the network or on your computer that isn't necessary. Yeah, I'll show a demo of that in a little bit here. Basically, all the labs are going to have a payload. They're going to call back to a Kali machine over here, and then you can set that, and then it'll be completely blocked. So kind of some of the big ones that are predefined that we're going to worry about is RDP. That's going to be operating over port 3389. That's going to be a application-specific firewall rule, which basically means that rather than just allowing any application to use port 3389, it's only going to allow remote desktop protocol to use port 3389. And then file and printer sharing, there's two rules that allow SMB in. And then there's a whole bunch of other file and printer sharing ones too, but SMB is kind of the one we're going to be looking at here. You can also create custom firewall rules. So you just go to, you right click on, once you get there, you got to right click new rule, go to the next setting, and then you're going to want to stick with program or application firewall rules, because that way that only that application is allowed through the firewall. Yeah, so want to allow the connection or block it or whatever. You can set those options. And that basically brings us to our lab. Some of the tips I kind of want to go over is don't block inbound connections from scored services. You're gonna, if your Windows server is running SMB or RDP service or a web server or something like that, and you block that, well, the scoring engine's not going to know that's there, and no one else can access it. You're going to start getting, you're going to start losing points and stuff like that. If the client isn't being scored, just block all inbound connections. That way, like, nothing can talk to it that doesn't need to, and you can just talk to everything else that you want to. Only allow when the application connections necessary. Don't be allowing like a VNC connection in, which is I don't know what it stands for. Basically, it's just going to be a screen sharing software that red teamers can use to look at your screen. I'll show you how to run that in a little bit. And then, like I said, like if you have enough time, by all means, configure your outbound firewall rules, your egress firewall rules. Especially if like red team is just all over your box, just like block off all your outbound, most of your egress firewall rules, or most of your outbound firewall, so that way like you have time to like secure your box and kick them off and just destroy their persistence and get rid of their users and backdoors and things like that and their firewall rules that they might have implemented. Yeah, so, and then like I said, use application and program ports for application program. It's called program in the firewall, but it's the same thing as your application rules versus just using the ports. And then we're going to kind of get into the demo here. So if you go to flash.defsec.club, you should have a Kali box and a Windows 7 box to look at. So don't quite open up the Windows 7 box yet. I have to get a multi-handler running here to get all your shells. Oh my goodness, how do I open up a
Actions web console. Oh, with the details first. Oh yeah, you gotta be in the VM first. You're currently, yeah. Three dots. So go back a step.
Here, how about we just go like,
Or you can use Flash, that's true as well.
yeah. So yours can have 2 boxes on yours. Just go ahead and open up the Windows 7 box, and let's see here. Yeah, okay. So if you get the Windows 7 box, if everything's all set up nice, I should start receiving a bunch of payloads from you. We'll deal with those later. As soon as you hit run on the thing that shows up, as soon as you log in, it should like call back to my computer. So let me go ahead and try that. Looks like I got a few random interpreter shells from y'all. We'll just let that chill there for a while. Password is going to be password one bank for those of you that don't know that. So if we open up a command prompt, we're going to be able to see, type in netstat, we should be able to see that there's a connection to my Kali box, which should be 50.36. So yeah, we'll just leave that guy there for a bit. So say that I log onto the Windows, box, and I go check my firewall. I want to turn that guy on, right? All the domain profiles are going to be off, or all the profiles are going to be off. So we're going to want to change that. Found this way to be a bit faster than the other way. So you just go ahead and click Use Recommended Settings, and it's going to automatically block all your inbound connections that don't match your firewall rule. So let's see here. This guy didn't update. Yeah, so yeah, now our firewall's all up and running and stuff like that. But let's go ahead and like see if we can start, actually let me see my IP address. So yeah, I'm gonna set you guys can do this as well. You can try, I put some resource scripts on your Kali boxes if you want to try attack your own box, just to see if your firewall is working. So we go right here. I'm going to set my remote host to what was that, 47, I think. No, 46. As you can see, it started the exploit. So basically that means our SMB v1 or SMB port is open and SMB v1 is enabled on our Windows 7 thing. So what we're going to do is go to inbound rules and kind of scroll down a little bit here. And we're going to you want to find file and printer sharing right here. And if you disable that, That's like I said, that's gonna block any SMB incoming connections to your computer, and it's gonna completely make your Eternal Blue not work, and you're not gonna get a session or anything like that. So yeah, continuing on. So say they try to start remote desktop. They want to come at our computer with a remote desktop connection. Here, let me make sure this guy's enabled quick. So do that. Okay. And they type in something like our desktop, or they start launching Eternal Blue on the Blue Keep on that on our machine. So go to 10.30.50.46. This may or may not work. I haven't tested it. Yeah. Okay. Yeah. Okay. So as you can see, this Kali box was able to get a remote desktop connection to our Windows box, which is something we don't really want if we don't want RDP on our computer. So another thing at the firewall level that we can do is block that as well. Yeah, so there's going to be two settings that you can go ahead and click disable. The remote assistance one I think is more for you give someone an access code, and then they can come and assist you on your computer and stuff like that. But yeah, you might as well just go ahead and disable all these guys too. So you can select multiple firewall rules by just clicking on the first one, holding Shift, and going all the way to the top of the one that you kind of want to disable or enable. So yeah, we're blocking all remote assistance connections and remote desktop connections to our computer. So if we go back to our Kali machine, yeah, so it shows that the session crashed. So yeah, that basically means that we were able to successfully block that from the firewall. Continuing on, so I want to see. Let's see if I can find my session here. So mine was .46, so that's session 14. So there's an interpreter shell. This is on my Windows box, and say like they have a VNC connection going on there. Let's see, let's just run VNC. Ooh, that didn't work. Oh, that's because I tried a different one. VNC, there we go. Okay, that did work. So this isn't actually my Windows 7 box. This is my Kali box with a VNC console. So this is basically the attacker looking at this guy right there. So here I'm the administrator. I'm sitting there on my computer, and the attacker can literally sit there and watch me type in whatever I want. They can log commands with that, or they can log our keystrokes with that interpreter command prompt and all that stuff. So what we can do to one of the methods, like I mentioned earlier, that you can do is do some stuff with your outbound rules to just block anything that's shooting out of your computer. And so if you go to properties, if we all do this at one time, I'm gonna have 1,000 interpreter sessions just kind of die on us. And for your domain profiles, your private profiles, and your public profile, just hit block right there. So let's watch this here. As you can see, there's the Kali machine on the left, and there's the admin machine on the right. Go ahead and click apply right there. I didn't actually click block on all of them. Okay, let's try that. Yeah, so that basically killed their interpreter session, and let's try to interact with that and see what happens quick. So that killed our VNC session. Yeah, so the guy is no longer, we can't use that guy anymore. Actually, I think it's because I typed the exit command, but really it killed the thing. Let's try, does anyone up here that has the IP, any of these IP addresses? Are any of you guys, have any of you applied the outbound rule at all? So we're talking 10.50.54, 10.50.64, or anything like that. So if any of you applied that outbound rule and I tried to interact with you, sessions I like 15. That guy didn't apply it, so I can run BNC on there too. And all that good stuff. But let's not, because that takes time. Or not. So yeah, it's just some of the things you can do with the Windows firewall. Let me see what else we can talk about here. So say that like you all of a sudden magically have your SMB service that needs to be scored. All you have to do is just go down here in your inbound rules, go to file discovery. Or file and printer sharing, then allow that. Enable rule. And then the scoring engine can interact with you. And then say your Windows, or say that remote desktop needs to be accessed, or you need to, or like one of your injects is to allow the CEO or someone to do that, to go into your computer. You just go ahead and hit those two guys, enable that, and then so you see this guy right here, allow remote admin. So it looks like this is an executable that's just chilling on the computer. I don't know what it is. It says Kathy.exe. I don't know why there's a firewall rule there for it. It's kind of suspicious. So let's go to, oh, there we go. So go ahead and run that guy. And we are going to, we should have, oh, I never shut the, so if you want to test all this stuff out, I made some resource files on the desktop that you can go check out. I'll show you how to run those and make a payload that you can throw on your computer quick and then test all that stuff. So interpreter session, okay, that's not the right IP address. Okay, there we go. So that new firewall rule that we allowed, that's now open on, or that actually called back to the attacker. So run back to our Windows machine, and like, okay, just to kind of show you the same thing as last time. Was that 22? actually, I don't even think we need to do this. So that outbound rule allows the attacker to have the interpreter session on the computer, as you can tell. However, it doesn't look like VNC is able to run anymore because it's going to run out of a different port. But you never know. Let's go ahead and disable and click disable on our egress rule here. Let's go, that should, actually I don't even know. It's going to stop Kathy from creating any further interpreter cells on her system. And it killed the interpreter shell as well. So you're going to want to go through and audit your firewall rules and make sure all of them are legit and stuff like that. So right now, if I want to open up a web browser and go connect to the internet, let's try, what was it? We're not going to be able to. So let's see if I installed Firefox. No, I didn't. Okay. So we're going to have to go create an outbound rule to allow internet to talk, to allow Internet Explorer to go talk to the internet and come back with stuff. Let's see here. Are there any other services like LDAP that have other services dependent on them? Yeah, so there are going to be services that are going to be dependent on some of these firewall rules. So a lot of the times they're going to be predefined and they're going to be allowed through, they're going to be predefined in the Windows firewall. And yeah, so you just go ahead and enable those. We can go over those if you want. So when do we get to learn about the firewall? Okay, nice try. What is an SLA violation? SLA violation, that's just basically means after like 3 checks by the scoring engine that you're not going to, you're going to start losing points. It's called the service level agreement if you're curious what the acronym stands for. Password for Kali is Tor if you want to mess around with that. What would happen if you selected all the rules and deleted them, not just disabled? So Windows Firewall has a default block on everything, or has a, basically if there's not a rule for error. Okay, so it really depends on what we have set up right here. Let's see here. So it depends on like if we just default block everything. So if it says block default and we just have all our firewall rules deleted, then it's going to be the same as this guy, block all connections. And same with this guy. So if we block that, then literally no application is going to be able to talk on the computer to the internet. Yeah, so let's go ahead and make that rule for Internet Explorer. So we're going to go to outbound rules, new rules, program. We're going to go to, actually there might be a predefined one, let's see. Yes, there's not a predefined rule for Internet Explorer, so we're going to have to go ahead and make our own program rule. So go to next, this program path. We got to find Internet Explorer. I think that's the right one. So go that, next, allow the connection, next, next. Another option you could do is just allow port 80 and 443, but then the attackers are going to be able to utilize those ports to use for their shells and stuff like that. So, if everything went as planned, we should be able to go to google.com or something like that. But we can't, so that means there's still something we did wrong. Or there's just no internet on the thing. Or on the network. But that's probably not true, so let's go ahead and try to ping google.com. Katra, is there internet on this network?
Try Chrome.
Okay. We just, it's not a big deal. We can just go to
Okay.
Yeah, so I've only done this actually. I've only actually done this on Mozilla Firefox, and literally all you have to do is just throw on the Firefox EXT and it works. Internet Explorer probably has a lot of other components involved in it that you have to exit. So I don't know what this did. This might have actually just completely messed up all the firewall rules that we did. Let's go ahead and look at our profiles here. So yeah, probably just added a bunch of outbound rules for Internet Explorer. Yeah, so that looks like that's what it did. It automatically added those two for us. And so now Internet Explorer can talk out to the internet, which is bad because like if the interpreter shell was migrated over to Internet Explorer, they could still talk out to it or talk back to the Kali machine. So I mean, outbound rules aren't bulletproof, but I mean they're a lot better than just having no outbound rules. Egress filtering is something you should really utilize. And it's going to make your attackers quite angry if you can do it right. So, yeah, I think that's basically all I had to talk about. Is there any more questions that you guys had at all? That wasn't super clear. Just kind of take a look at the slides a little bit more. I'll post those up in a little bit. It should hopefully bring some of this stuff together for you guys. Anything? Yeah, so that's going to be it. Actually, wait. Are any of you interested in actually testing the interpreter shells on your own computers at all? Okay, perfect. Alrighty, so that's it. Thanks, guys.
So we got links to go.
Yeah.
Try to make it quick, so.
Perfect.
Could you leave that up for questions?
This guy? Yeah. Sure.
Yeah. Just gonna take me half a second to log in there. Oh, I will automatically suspend soon.
What's the link at? What's the link at?
Questions.defsec.club should get you there. Okay, looking good. Yeah, I'll punch those in quick here. As I said, guys, I'm going to try to get through this fairly quickly. Okay, awesome. As always, guys, if you have any questions, please raise your hand. Please ask questions on here. If I'm going too fast, too slow, whatever, speed me up, speed me down. It's content's for you guys, so you control the flow of that. And I got all my, DefSec normal slides. DefSec IP tables is the VApp we'll be using. If you haven't, hopefully all you guys should have it at this point. Assuming you filled out attendance for the last one of the days for the last 3 weeks, you should have it. Oh, great. I'm just going to pull mine open real quick. So, our VApp's going to have a client, it's going to have a server, it's going to have a pfSense box. We're mostly going to be focused on the server, maybe a little bit on the client. Don't worry about the pfSense box at all. I'll get into that just after we go through a couple slides so we get a good background on what I'm actually going to be talking about. So, and I don't have more I don't have more general stuff, but what's IP tables? IP tables is a firewall you're going to see on Linux. It is command line. There's no GUI. On many Linux systems, there will not be a GUI. We don't like GUIs on Linux because they're bad. The reason they're bad is because they're slow. But in general, IP tables is the #1 firewall you're going to come across. You might see things like UFW. All UFW is a wrapper that goes on top of IP tables and just sits on there and, you know, adds some bloats and maybe makes things a little bit easier to use, but we also don't have UFW on quite a few systems, and because of that, we teach IP tables. We teach basically the lowest level we can get down to where you have full control. And it might be a little bit slower than if you had UFW, but it's pretty much guaranteed to be there. There will be some systems that do not have IP tables. They will be the Solaris systems. They will be the BSD systems. If you're Red Hat, Debian, you're Ubuntu based, you'll have IP tables. If you don't have IP tables, you can tell you're in a bad system because nobody likes Solaris and nobody likes FreeBSD except people who like routers. So those are the two systems you're not going to have IP tables on. Just going to jump right into it. We're going to do some general stuff, and then we're going to jump right into the VApp. So please have the VApp ready to go. Thanks, guys. A GUI is a graphical user interface, for those of you who do not know, which is fine. And I've already had requests to speed up, so I can only go so fast, guys. Talking about IP tables, there's kind of two main concepts on IP tables. There's chains and there's rules. Chains are these overarching bundles. They decide when the rules are going to be executed. Normally we have an input chain, a forward chain, and a drop chain, guys. Okay, that's a typo. Sorry, input, forward, and output. So when a packet comes in, that's going to be executed on the input chain. When a packet is being forwarded for whatever reason, that's going to be on the forward chain. And when the packet goes outbound, it's going to be on the output chain. That drop is not supposed to be there. So just going to go over that quick and show you guys what I'm talking about. The main advantages I'm going to talk about as far as IP tables over UFW, that was a question, is what are the advantages of IP tables over UFW, is I don't know why that is not, my terminal is not loading. I guess we'll have to go right into here. So first of all, we'll pop into the server quick because my terminal did not load on Linux, which is very odd. Server VM, user count login, straight as root, guys, and it's going to be password one bang for the password. Thank you for loving my background. I appreciate that deeply. But the advantages of IP tables over UFW is that IP tables is more or less guaranteed to be there. UFW is a wrapper that goes on top of IP tables. All it does underneath is run IP tables rules. So if you have UFW, you have IP tables, but you might not have UFW, especially if you're on a minimal system, which means you get on a system without UFW, you now have to install something before you can even set up the firewall, which is not the greatest scenario to be in. So, getting right to the server, as I said, user count was root, password is password one bang. To even use IP tables at all, we're going to do an IP tables -L, and we're going to get into more listing options. But looking here right now, we have the input chain, the forward chain, and the output chain. That's all I'm trying to get across here. We have 3 chains on our default IP tables command you run it. You're going to see the 3 default chains. However, popping back over here, we also have some additional tables, which we're going to use for some different routing. It's not your typical stuff for what we're concerned about. You have things like the NAT table. I wouldn't worry about that too much. The core here is just how to defend your stuff, and for that, we're just going to focus on the main table. You'll need the NAT table if you're trying to do some more advanced stuff like set up a Linux system to basically be a router. But if you ever want to see those, it should just be that. We use -T to specify the table and L list. We'll get into that later for all the options for related to that. Thank you. I will zoom in next time. What's a firewall? Oh, Firewall D? Oh, gosh. If I remember right, Firewall D is something you're going to see on more Red Hat-based systems. I haven't worked with it a ton. Ironically, it's running on my stuff. It is also a wrapper for IP tables. There are multiple applications that wrap IP tables because for some reason they don't like IP tables, even though I really like IP tables. So that's all Firewall D is another wrapper that's intended to make things easier and more secure by default and whatever else, but it's just sitting on top of IP tables doing IP tables rules. But as I said, we have our chains. So getting into that, they have a default target. Normally your two default targets you're going to be working with is either accept or drop. So if we look over here again, just for the same output we got last time, and I always hate with the ILM I can't mouse over the VM because it eats my cursor, but you'll see right here we have policy accept. That means our default policy for anything that goes into that chain will be to accept that packet. If it does not match a rule, it hits that policy, it will accept. If we have it set to drop, then the default policy will be to drop the packet. So if we don't have a rule for it, it gets dropped, or in this case, gets accepted. And then here are the commands to change the policies. The key thing to understand here is the -P is the policy flag. We then have which chain we're working with, which is in this case output. And then we have whether we're going to accept or drop it. And okay, yeah, we'll do this. My bad, guys. Is that sufficiently large? Hopefully that should be much better. So I'll go over that one more time in case you guys didn't see. We have our chain. We have our policy. Yeah, this is fantastic. Here, guys, let's do this. So in this example, we have our chain post routing, which is part of the NAT table, which we're not going to worry about, but same thing goes for like the chain input. And then we have the policy, which in this case is accept. The policy could be drop, in which case we drop the packet if it doesn't match the rules. In this one, though, our policy is set to accept it if we don't have any rules. So that's all that's about. So with that previous example, if we do, oh, I forgot caps lock doesn't like participating in VMs sometimes either. So this one's actually going to do nothing, but what this should do is we're using the IP tables command, we're doing -P for the input chain, and then we're doing accept. So what that would do is change our input chain to accept, which does nothing because it's already set to accept. But if we were to set it to drop instead, and then do IP tables -L again for list, we're going to see our input chain has now changed to a policy of drop, meaning we're blocking all the input into this VM. A packet will come in, it'll go into our input, as that's where all inbound packets go, and we will then drop it. So that's where we're set right now. We're actually blocking everything inbound. Okay, question during the Cyber Conquest, it said I had to use the IP tables command in the form of a question, is that normal? No, that is not normal. One of your boxes of Cyber Conquest, I changed the IP tables. I didn't modify the binary, I moved the binary, but I replaced it with a shell script that would ask, which would tell you for IP tables that you had to use it in the form of a question. So if you wrote IP tables what is and then your rule, it would let it through. That's not normal. I did that. That's bad. That means something's broken. You should fix that. So no, that's not normal behavior. And you'll see this in competitions. If red team's super mean to you, they'll break your IP tables right from the get-go, and you'll have to fix it first thing you do because they don't like you using firewalls, because firewalls will block, I'm not going to say 90%, let's give it 60, 70% of all the issues with your system, because you can narrow down using a firewall to the very precise things you want to choose to actually work with and protect, because everything else is just outright blocked. So that's why they're going to be breaking firewalls, and that's why that was broken there. But moving on. Default policies. Okay, chains are the overarching thing. We have many rules in a chain. Chains are the lower things. So, as I said, we have the three chains we're worrying about, which is our input, output, forward. No typos in this one. And the rules will normally be set up in the fashion that they're going to jump to something. So normally this is either accept or drop. We want our firewall rule to either accept something or drop something. We also have some additional targets. We can reject it instead of drop. The difference there is one of those is going to reject it with a packet saying, no, you're bad, stop trying to talk on this port, and one's going to say just nothing. It's not going to say anything at all. It's just going to drop the packet and move on with its life. It's going to basically be a black hole. We also have a target in Linux called log, where we're going to log the packet and log that it went through, which we're going to get on later. We got another question here. If red team is already on an SSH session and you set IP tables to drop it, does it drop their connection or leave it and block future? So this is basically a stateful, non-stateful question. They're basically saying if we already have a state for this SSH connection, then we drop, and I'm assuming any SSH connections, will it stay there? In Linux, it will. The reason here is because we're not talking about netstat, we're talking about IP tables here. The assumption is you're dropping, and once again, this is very rule specific to what you set up. But in this scenario, yes. If you deny all SSH connections and then you work with the firewall we have set up and we're going to be working with, then it'll let that session through. You'll have to kill it manually. But we'll get into that later. But back into rules. They're going to jump to one of these targets, accept, drop, reject, log, and it's going to take the first match. That's very important. We go down the chain, we take the first match. Just some other stuff for how we can input them. We can either use the -A flag, in which case it's going to append to that. It's going to put it at the very bottom of the list. We can use -I to insert it at a certain position. In this case, it's 1. So it's going to put it right at the top of the list. And then we have -D to delete rules. When you do eventually mess up on IP table somewhere and you have to delete rules, it's nice to remember. The count for both of these will always start at 1 and go onward. IP tables, the list of rules is not an array. It does not start at 0. It starts at 1. So keep that in mind. We'll go over that later where we just go through stuff. For IP tables rules, when we start writing rules here in a minute, we have a lot of different options for IP tables. The ones we focus on are going to be ports and IP addresses for a firewall. We're not doing application stuff. We want to filter out IPs or we want to filter out ports. That's what we want to prioritize on. So P is the protocol, which it's technically not. That's true. That's not port stuff. That's the protocol, which is either going to be normally TCP or UDP. Occasionally, we'll do some ICMP stuff if we want to mess with ping. In general, if ping's not allowed, just block it because who likes ping? But occasionally you want to write an ICMP rule. Otherwise, it's going to be TCP or UDP. -D is the destination IP flag. -S is the source IP flag. So that's either what IP the packet's going to or what IP the packet's coming from. We also have -D port and -S port. That's going to be the destination ports and the source ports. That's basically what it sounds like. If we're going to a web server, the destination port's always going to be port 80, but if we're sending to the web server, because that's what the web server port is. That's what those two do in general. -I and -O are going to be the inbound interface and the outbound interface. Those are some weird ones. We're only going to use this for a single rule. Normally, we don't really care about the interfaces. We let the system handle that. We just deal with IPs and ports. But there will be one case in which we're going to care about that. And then -M is use a module. And this is the big one. This is the annoying one. This is why I have a lot of people who have been Linux admins for a while and they still, struggle, have to go Google things to write IP tables rules, is because there's so much in that -M flag, because we can specify a lot of additional modules that do things like allow us to manage state, or specify multiple IP addresses or multiple ports, or a lot of other stuff. So that -M1 is a huge little section, but for the most part, we're going to stick with these up here. We already did that for IP tables -L, but some additional flags is we can do -V for verbose. So I'll show that quick here. Something else to note, you cannot, for IP tables, you cannot do this. You have to give them each their own dash. They're very sensitive that way. So in that case, and you actually probably won't even see the difference there. We'll go through it later. But if you notice, we have some additional headers there besides what we had before. I'll do -numeric in a second. Actually, we'll save that one because it won't do anything because we have no rules yet. So we'll get into adding rules here in a second. And actually, I'll just add some rules so we can actually see what's going on here, guys. So going back to how we actually add rules, we're going to add a super simple rule. So this is -A, so we're going to append it. We're going to append it. Once again, caps lock does not work on VMs, apparently. We're going to append it to the input chain. And I'm already messing that up. There we go. So that's a ridiculously basic rule. What that says is we're in this row of the input chain, and all the rule does is it doesn't even check the filters, it just accepts it. So that meant that this rule just accepts everything that comes into the input chain now, regardless of what it actually has filter-wise. I just want to demonstrate that if we look here now, that's what it looks like. You can see it up there right underneath the input chain. It's just chilling right there. And then you notice they try to make it nice for us by having like words like all and anywhere there instead of giving us, fun things like verbose will just add extra fields. But numeric is what I'm talking about. And what that'll do is convert them all to the actual IP address ranges that those actually mean. So 0.0.0.0/0 means anything. Any IP address matches that range. You guys will get into that more. We kind of went over there a little bit in networking 101, but just keep in mind if it had the /0, that means everything for this is going to match that range. /32 will mean only that one address. /0 means all those are network bits, so it will match any address. But that's what those are for. Occasionally you don't like to see words like anywhere, you actually want the actual numbers, but it's also simple enough to leave it as is. So now we're just going to probably jump, and then if once again back on that flushing slide there, if we do IP doubles -F, what that does is that flushes the entire table. It just removes all the rules. So -F, we're going to do IP tables -L again. Thanks. And we're going to see that rule is now gone. IP tables -X is on there. That's a capital X, of course. That deletes all the user-defined chains. We don't care about that too much. That's a pretty minimal issue. Actually, that's table. Yeah, it's user-defined chains. So you can create your own chains. That gets a little more complicated. If you run -F and -X with something like Firewall D running, it'll wipe basically everything Firewall D does out of existence besides the default policies, which is why it's very important to remember that -F, if you notice, it got rid of that rule, but our policy state up here is still drop. So if you guys flip the policies down to drop and then you run that, you're now blocking all connections to your system. The reason I bring this up is because occasionally in competitions and real life, you have remote systems. These remote systems you don't have a physical access to, you don't have IALAB access to, you are only managing them over some tool like RDP or VNC or SSH. And if you switch your policy states to drop and then flush all the rules on the table, you no longer have access to that system. It will cut your connection instantaneously and you'll be locked out. And that's happened, quite frequently in competitions, to be honest. It's a pretty regular thing to have somebody accidentally lock themselves out of a box because they wrote all these rules out and then they decide to flush them for whatever reason, and they knock themselves out of the box. So keep that in mind, that -F does not change policies back to accept. It will leave them wherever they're at. So now getting into actual rules. We're gonna base this on a scenario here. So we're gonna pop open our client box just so we can demonstrate this quick. So we're gonna log in using root again, because who doesn't like super user permissions? Oh, what do you do if you lock yourself out and you're in a competition? That's when you make the decision to either revert, find some way back in, which if you did it this way, there's no way back in. So you can either revert or you can cry. That's your two options. Because you're not getting back into that box if you don't have physical access. You can revert it, which will likely cost you points, or you can cry. That's your options. Or if you're like at Argonne or some other long form, they'll probably, let you back in, but that's before the actual competition started. So, and I don't even need to do that, but this is our client box. So the client box and the server box are on the same network. What I'm going to do here is I'm going to use the nmap command, which if you don't know what that does, it's just going to scan that IP and it's going to look for open ports. So in this case, we're going to scan 1.10, and just so this doesn't take a year and a half, I'm going to add -T5. What -T5 does is basically tells nmap to speed up the process. Nmap, if you notice, it actually, now it doesn't say it there because I put T5, but it'll normally tell you it's doing a stealth scan because nmap is designed to be stealthy and take a long time, so administrators and security people won't detect that you're scanning them. But -T5 is just like, no, send all the packets. I don't care if anyone detects it's me. I want to know what's open right now. So it probably broke, didn't it? Of course it did. Which, ironically, you want to know why it broke, guys? Because we set that really awesome policy state over here to drop everything inbound. So we actually secured the system. That's how you do it, right? Just block everything. It'll be okay. So we're going to, back in the server, we're going to change the policy state back to accept so I can actually do that nmap scan properly. I wish it was just perfectly, there we go, that's better. So From the client, we scan the server. We're going to see that we have a lot of ports open. We have FTP, SSH, Telnet, SMTP, domain, DNS. I don't know what this doing. You gotta love the MF developers. HTTP, RPC, and so on. We even have some, services you'd find on normally Microsoft-based boxes, Windows, because it's running Samba, which was also during Cyber Conquest, but I'm probably not going to talk about that too much because I want to keep stuff rolling. So we have a lot of ports. We don't need all these ports. Let's assume that we're competing in a competition, and these are all the ports open in our system, but we only want, let's say, 22 SSH inbound and port 80 inbound. So those are the only ones we want inbound. And then outbound, let's say we also want port 80 outbound for web, so we can update. We normally do that over 80 for Linux, actually. But we'll let out, let's say, 80, 443, and DNS on both protocols. So that's what we want for our firewall. So that's the scenario. We want 22 inbound, 80 inbound, and then we want a couple ports outbound so we can do things like update and use DNS. So that's the scenario we're going to use here, and now we're going to construct a firewall for it. So let's make sure there is, to the best of my knowledge with IP tables, there's not any real way to edit an existing rule. What you'll see later on that it will generate a file, and you could theoretically edit that file and reload, but you're still not editing an existing rule. IP tables is not set up in that manner. But yeah, so this is our blank slate of a firewall. And let's just start adding some rules here. So we're going to do IP tables -a for input. So we want to allow, as we said, we want to allow port 80. So in this case, it's going to be, we do have to specify a protocol to get D port, actually. So input chain -p means protocol for TCP, --d port is going to port 80, and then we're going to jump to accept. So accept's our target here. What this basically means is anything coming inbound on TCP and port 80, we're going to accept it, which is going to be pretty much not all your web traffic, but it's going to be all your unencrypted web traffic. So we're going to add that one. Go into that. And then we're going to also add another one. Actually, we're not going to do 443 in this one, but we are going to do 22. So I'm just going to modify that one quick in place. So I just pressed up arrow and then, use the arrow keys to go back. And now we're basically doing the same thing, except we're doing it on destination port 22, which is the port for SSH. So I'm going to press enter there as well. So now we're allowing 80 and 22 in, kind of. And then we're also, let's just right quick here, because we're going to get into the whole reason why nothing can be simple in life and everything has to be complicated. And we said before we want to allow traffic outbound to 80. And then we also wanted 443 because 80 and 443 are our web ports. And then we also want to allow DNS. For the purposes of this, I'm going to allow DNS on TCP and UDP. Because very occasionally we have DNS over TCP, and I do forget why that well, I vaguely remember why that is, but it's just best to allow it on both. That's true. DNSSEC is the better reason. So there is reasons to allow it on TCP. You'll probably get you'll almost certainly be okay if you allow just UDP outbound, but I do it because I don't want to have random TCP problems in an hour and a half and be like, I have no idea why it doesn't work. I'm allowing it and everything. But so you would think if this was a simple world, this would work, right? Where we have 80, we have 22. This is everything we're talking about. We're allowing 80 and 22 outbound, or sorry, 80 and 443 outbound. We're allowing DNS outbound. We're allowing 80 and 22 in, but this doesn't work. And the reason it doesn't work is because we haven't done state. And that's the key with a lot of firewall rules is these are the ones that people normally forget, and because they're weird. We have state in a firewall. What state means is that we keep track of rules coming in, and we see whether it's new, whether it's related, or whether it's established. So if it's new, we want to always evaluate it and check whether it should be there. But if it's established, we normally don't care as much. Because if we have a connection coming into port 80, so it's going to a web server, and it's coming from an address, let's say it's coming from 1.1.1.1, that's the source address. It's coming to our whatever our destination address is. The source port is going to be whatever. The destination port is going to be 80. So we're going to look at it and see it's 80, but now we allowed that through a firewall because we said, we want 80 traffic in. But going outbound, it's going to be a weird source port on our side, and it's going to be a weird source port on their side. And normally we don't want to deal with, that's true. So we don't want to have to deal with all that weirdness. So normally we just deal with state. And in this case, what the top two rules mean is for our input and our output chain, we are going to allow any packet that we've already seen the connection come through at least once, and we're going to allow it to keep talking. So we care about the first connection. We filter those very hard, and then once you already have a connection set up, we basically just let you do whatever you want on the same port and the same connection is what we care about. Wouldn't it be S port 80 for out? Okay, so some things to note is that when we are setting up sockets on actually any system, they're going to have a destination port and a source port. The reason it's not a source port of 80 when it's going out is that we can only have one port for one socket. So if we had 80 for our source port, now we can't have it for our destination port because we can only have that for one socket. So instead we assign a different source port for that connection, and then that's going to be going to a random, to whatever they replied on for their destination port. So it gets nice and complicated. Unless I'm wrong there and I'm just crazy for some reason.
You might be wrong.
Oh yeah, I think I'm just messing it up. No, you're right. You can do source port 80 out. The reason we don't deal with that is because it's painful, and you now have to write two rules for every single connection, one for the source port 80 out and one for it coming in. So we have to double our rules up. Here we have to write the two rules at the very top, and that takes care of half of all of our connections, and the inbound will take care of half of all the other connections, or the outbound, same idea.
And the reason you didn't do it earlier is because you wanted outbound traffic from the server to actual web pages.
Yes, we wanted two actual web pages, and we wanted it just to our own web server that we're hosting. So we're going to fix that right now. We're going to write those in. Oh my gosh. I really don't like holding down the shift key. Yep. That's actually really weird why it's doing that. Okay, so occasionally you have this beautiful issue where the caps lock key will get turned on inside your VM and not turned on. Here, 1 second, I'm going to fix that. There we go. Which actually didn't hurt me here, but it gets really annoying later on. So what that's saying is we're going to, for input, we're going to allow anything that's related established, and then we're going to copy the same rule and just change it to output. So, for the purposes of, yep. We're going to have to figure out how to fix that one someday. So that one did the same thing for output. So now, if we scan, I'll look at that one in a second. It probably does. Oh, I think no, okay. So, something we did forget to do. I forgot to do. If you notice, actually, yeah, our chain for input, our policies are still accept. Once you've set up your firewall rules, it's very important to note, especially if you're using a remote system, you don't do this before your firewall rules are set up unless you want to block everything, which you can do in a physical system, never do in a remote system, is we need to change our policy states to basically be dropping everything we don't accept. So here, okay. So we're not going to worry about forwarded chain for this moment. We changed all of our stuff. We'll look at that one. There we go. So now we're seeing, instead of our giant list of all the ports we have open, we just have ports 22 and 80. That's all we're allowing inbound. We can look at questions now. We'll go into IP table save in a moment. That'll probably be the last thing we do. If we did IP tables, I'm just going to show you guys so you can see what the person's talking about. I don't know if they mean whatever extra stuff they have there. So, gosh, I don't know 100% what you're trying to do there. Because what that rule looks like is we're trying to block anybody who has a certain range. But what basically yeah, I'm not exactly sure what that person wanted to get at with that one. It looks like they're trying to block a specific range of IP addresses. We cannot use that sort of wildcard in IP tables. We have to use multi-port, which is one of those -M module flakes. Which, if I didn't make clear when we're looking at these weird ones, is we have to use a module here to do state. We're not using the other options. We're using some of the modules to deal with. So we're using the state module, and then we're invoking the /state option, which is where what we give the related established to here. Yeah, so can you block the attacker subnet? Is this possible to do? Yes. Do we allow it? No. And this is the reason we don't allow this is because in an actual enterprise environment, let's say you've services and they're not facing this scoring environment, they're facing the internet. There's a lot of IP addresses on the internet. Somebody tell me, what's the attacker subnet on the internet? Well, I guess. Yes, it is. I mean, you could give me some, nicer answers like, we'll just block China, which some people do. Some people block IPs based on geolocation. But in general, if you block someone's IP address on the internet, they're just going to get a new IP address and they're going to attack you using that new IP address. So blocking the attacker IP address or subnet might slow them down, but depending on how advanced they are, it's not going to slow them down by much, and it's certainly not going to stop them. In a competition, does the scoring engine only need the scored services to have rules in the inbound chain? In general, there's some exceptions to this. For 80, we only need 80 because that's what's scored. Some other services will use additional ports beside whatever the scoring engine. So here's the thing. Normally, the scoring engine is not going to tell you a port. It's going to tell you a service. It's going to tell you it's using FTP. Well, guess what? FTP doesn't just need port. What is it for 21? FTP does not just need port 21 to work. So we have to deal with whatever the extra stuff are. The scoring engine's not going to tell us, keep port 21 open. It's going to say keep FTP working. So for example, for FTP, we have to deal with some passive FTP data transfer ports as well, which is why that one, sucks to write rules for. Could you set up IP tables to only allow anything with a scoring engine IP? Once again, you could do this. We also don't allow it. For the same reason, for the really diverse reason. On the internet, we don't know who our attackers are, but we also don't know who our customers are. Yeah, Dave, I know you're a 60-year-old person trying to do his taxes, but please give me your IP address. I need to whitelist you. Is not going to fly very far with your customers in an enterprise environment. So that's also the reason why we don't allow a lot of IP address blocking specifically. What we expect you to do is we expect you to block ports and allow ports. That's what we expect you to do. That's what we encourage. We don't, if we allow IP addresses, and this is not just our rules, by the way, this is national CCDC rules, and pretty much any cyber competition you're in, they're going to restrict your blocking of IP addresses to some degree. But yeah, we don't really like you blocking them. If you block them, you have to block them dynamically, and you have to block them for a set time period, which many competitions might even make you justify, is this reasonable time period? Because I can tell you, when you tell your customer you're blocked, for 2 years, dynamically though, it was automatic, we didn't press the button, it's not going to fly either. So normally you have to set them for some pretty low times, like 15 minutes or 10 minutes is normally you set those to. We are going to talk, last thing we're going to talk about, unless people want me to go back and explain things because, I rushed through everything. We're going to talk about how to do persistent IP tables. So here's a cool thing I didn't mention. Guess what happens when you reboot your system? It all goes away. All your IP table rules go back to the default. So there's a couple ways to get them to be persistent. We have, which I'll actually go over the wrong way, which is we can do IP tables save to etc rules.v4. So what IP tables-save does, which I'll just show you here, is it outputs them in this super, it's actually not that bad. It outputs them in this format, which means you can read them back in with IP tables-restore. which is what the fallback is for. We can echo means we're going to echo it to the console, but we're going to redirect it with this little sign right here to etc.rc.local. I'll show you that one right there. So what that one does, oh, my bad. And we're going to echo it to, oh, no, my bad. Completely different thing. Yeah. So now if we cat, we're just reading that file. That's, okay, I did the wrong thing. Great. Because I forgot that, which we'll fix here in just a second. This is supposed to be the nice way to do it, guys, and, you know, sometimes it doesn't always make sense. And once again, that is very questionable. I'm surprised that worked. But if you type what I wrote on the slides, it works. Yeah, so that's what we're putting in the rc.local file. For those of you who don't know, the rc.local file should be run on every boot. So all that would do is if we saved our file, if we saved our rules to rules.v4, this would run on every boot, rules-restore from that file and restore the IP tables rules. This is the bad way to do it. I do actually believe that because, and once again, depending on your system, rc.local is run on service startup. I don't remember where it gets startup. If you want to check that somewhere, Nick, for systemd. There might be a slight gap where your other services are up, but that has not been run, so there'll be a slight window of vulnerability. Also, it's just, you know, not the funnest to use. The right way to do it is we're going to do apt install iptables-persistent, which is a package that runs with your service, your system to basically do all this for you. And then you just do iptables-save to etc iptables v4, which will ask you at the very start whether you want to save it. So I'll get that installation going quick here. The other cool thing about Linux, guys, is, well, you know, we're going to hope we have internet here. Because I don't have to press buttons. Yeah, so this is what it'll do here, is it asks if you want to save your rules by default. So it'll actually make that file and that directory for you when you install the service. Are you allowed to block attacker IPs when you detect infiltration? Depends on the competition. For national CCDC, for regionals, I actually don't know what the rules are. For nationals, you actually are, but the reason they let you do it for nationals is because they have such a large infrastructure set up that they can change IPs in like half a second. So the time that you spend typing in the rule to block an attacker once you detect infiltration is more time than they spent changing the IP address. So yes, you can do it at nationals. For Argonne and a lot of the other longer form, I don't even think they'll let you do it there. It normally has to be dynamic. It has to be dynamic for those sort of competitions. And in general, that's what you should prioritize, is just doing dynamic, because that's normally, that's all that's going to be allowed. Another question. Are you allowed to set up IP tables to NAT forward everything inbound other than your services to another team's box? No, you can't do that. So just to give some context, he wants to NAT forward everything on our box to another system's box. What that would mean is everything that's not scored on our box goes to somebody else's, which means if they left insecure services, the attacker thinks he's attacking our team, but he's actually attacking a different team. No. That will get you disqualified very easily, because now, you want to know what that looks like at the network level? It looks like you're launching exploits against another team. So that's a good way to get kicked out, again. I hope I've made stuff clear. I know I went through it pretty dang fast. Any questions at anything at all I went over, or anything firewall, Linux related, or whatever? You can raise your hands or ask them in this thing where I just kind of come over here and just say words occasionally. But that was the general idea. Unfortunately, IP tables they're one of those things where, because we use them so infrequently, you only set up a firewall in a box normally once and then you call it good enough. Well, on a competition, you might redo it multiple times. But in general, when you're setting up your own stuff, you don't, modify that on a daily basis. It's something hard to learn. You just really got to practice with it. We do have lists out in the Google Drive for you to follow. I would also suggest that I think our next competition coming up is a standard blue team. So red team will attack you and you just defend. You're not going to attack anybody else. You're just a defender. I would suggest in that one, if we gave you info in advance, which I believe we will, write up your IP tables rules the day before. You will have to modify them because we will not have told you something that's critical. But write them up generally to save yourself time so you don't have to slug through making mistakes and going through that process. Get them up, practice them the day before, and just work with IP tables. Because once you get a hang of it, it's not actually that complicated, but there's a learning curve there where it takes some practice before we understand all the options and all the filters and kind of the underlying chain target-based system. Why do we want to block people and redirect traffic so bad? Do they have people monitoring the network in real time for the competition? That's what do you think White Team does? We're really bored, guys. We're really bored during the competition. We got to do something. Depending on where you're going, yeah, 100% they'll have people monitoring. They might not be monitoring for that specific thing, but in general, just because you can get away with something doesn't mean it's a good idea to do it. Because if 1 out of 5 times, or let's say 4 out of 5 times I get away with it, and the 5th time they disqualify me and kick me out of the competition, that's not good numbers. That's really bad numbers. Because then they kick me out and they ban me from competing again or whatever else. Can you download IP tables on Windows? I like that question because technically yes, but it won't work, is the answer there. Use the GUI Windows. Actually, you can also use PowerShell, I think, to do Windows firewall rules. I have no idea how well. Actually, I think we do that. We have for some of our scripts for Windows in the Google Drive, we actually do have you, I think, reset the firewall rules by default. If you want to learn how to do firewall rules off PowerShell, totally do it. I'm sure eventually you'll be faster than the GUI. I don't know at what period of time that is, but ironically, I actually support that more than I support the normal Windows firewall. Do we get access to the router for a defense subnet ever? So this is for Cyber Conquest, where we didn't give you access to the pfSense box. Yes. In fact, if it's not Cyber Conquest, we always give you access to your router. Next time, it's probably going to be a pfSense, I think. Unless we decide to give you a Palo. Palos are complicated, and they're basically all we use for nationals. That's why we'd give them to you guys now.
It depends on if we have time to cover pfSense before the next CCDC mod.
Oh, you think we might actually not do it?
If we haven't covered it yet, we're just not going to have a network firewall.
We should give it to them anyway, just change the password on it.
Well, yeah.
But we'll still
have access to it, basically.
Well, we could give them access and then just change the password so Red Team doesn't have it. If you wanted to give the people access to the firewall who knew how to use it, that's why it might be a statement. Yeah, we could probably do that regardless. So we could probably make sure you have access even if we don't necessarily teach you how to use pfSense. pfSense is one of those GUI-based ones that's not. Well, I mean, okay. Actually, most of them are GUI-based. But it's one of those that should be easier to use than Palo because it normally just focuses on ports and stuff we went over here, ports and IPs. That's what the basics are. And then we like a Palo, we get into filtering by the application. That's when we're trying to block you because you're going to Facebook or doing something that doesn't look like a web browser. It looks like you're downloading a file, or something that looks like you're doing SSH forwarding instead of just typing commands. That's what a Palo does. It looks at the application level and tries to determine what you're doing. It's also a lot more complicated, and Red Team hates it because it normally shuts them down really fast. But we're probably not going to have it for next competition. We'll probably have pfSense at most. Any other questions? Any other IP table stuff? Anything I didn't explain because I went through it in like 3 seconds and I'm way too fast or something? Okay. That's where we're going to end it for tonight. I have one more announcement, and that is apparently we are raising Computer Club dues to $15 instead of $10. So if you have not paid dues, pay dues now before we raise them to arbitrarily high prices. Okay. That's it. Have a nice day, guys. So that's theoretically, if you have not paid dues,
You pay Sunday.
you pay dues.
Yeah. Oh, yeah, it's the same.
Yeah. Okay, so I think, cash. You have no cash. That makes it You stop the stream, I stop the stream. That's all one for you. How long was your account? It was before. Thanks for tuning in. Stream is going to end.